Hi guys, greetings of the day to everyone. So in the previous session, we have seen TCP part 2. Well, I'm Monish and I'm from Network Assume technical team. So today's topic will be about TCP part 2. Okay. We have seen a lot of things in the previous session where we went through the difference between the TCP and the UDP, and also we have seen how all these things work. What happens if you use TCP? What happens if you use UDP? Right. So today we are going to see about the TCP header. We'll go in depth with the TCP header. So in this particular part 2, you can consider like we'll be going with the source port, destination port, sequence number, acknowledgement number, header length, and then the flags. So in the flags, we'll go with the part 3. But today I want to give a little bit in detail of the port and everything. Okay. So today it will be all about the TCP header. So as you know, the TCP header contains the source port, destination port, sequence number, acknowledgement number, header length, reserved, the flags, and then the window size, checksum, agent pointer options. So a lot of things are there, right? So let us go in depth with these particular fields. Okay. So in brief, if I have to say, source port is about 16 bits. It contains 16 bits. Destination port 16 bits. Sequence number 32 bits. Acknowledgement number 32 bits. Header length 4 bits, reserved 6 bits, and each of the flags will contain 1 bit. Okay. Window size 16 bit, checksum 16 bit, urgent pointer 16 bit, options 40 bytes. Okay. So there are lots of things, but let us go with the source port first. So what is source port and what is destination port? Why does this field contain the 16 bits? Okay. So mainly you need to think the total number of ports, guys. There are overall 65535 ports. That means 2 raised to the power 16. 2 raised to the power 16 is equal to 65535. And you can see here the source port is a 16-bit field that specifies the port number of the sender. Destination port is the 16-bit field that specifies the port number of the receiver. Okay. So this is been differentiated between the well-known port number and then the dynamic port number. For example, let me take in this way. Consider like this is your PC and you are connected to any one of the server or a router, whatever it is. And here you have enabled a telnet or an SSH. Okay. Telnet and SSH uses which protocol? TCP. All right. So here now consider the IP address is 10.1.1.10 and here the IP address is 10.1.1.11. All right. So now we want to take an access of this particular router or a server, whatever it is. Now during that time, you will have a source IP, you will have a destination IP, and even a source port and destination port. Destination IP, source port, and destination port. Because this is a telnet and SSH, that means it's a TCP based traffic. So here the source IP consider 10.1.11 and the destination IP is 10.10. And what will be your source port? Source port will always be what? It specifies the port number of the sender. It specifies the port number of this particular sender, and this particular port number will always be dynamic, guys. Will always be dynamic. And what are the range of dynamic port number? 10.0232 to 65535. And the well-known port number is from 0 to 10.23. All right. So in this case, if it is dynamic, it can be anything. It can even be in this way also. This is all dynamic. So we call this as in a common term a random port number on the source side, and on the destination, so it's destination side, it's all about the well-known port. So destination port, consider here if you're going with the telnet, what will be the port number? It will be 23. Okay. So this is basically your source port and destination port field in your TCP header defines whatever the port number your source is using and whatever the destination side you are going to access. Like for example, you can take telnet, SSH, HTTP, HTTPS. Okay. If you're going with the destination port, if you want to take the access of HTTP, then your destination port will be 80. If you're going to take the access of HTTPS, your destination port will be 443. Okay. So this defines the source and the destination. All right. So now This is all about, you can consider like for the source port and the destination port. The next we have what? Sequence number, which is 32-bit, acknowledgement number, which is 32-bit, and we have a phantom bit. So what are these things? What are these particular field contains? What is the use of this sequence number? What is the use of this acknowledgement number? Where do we use this particular sequence and acknowledgement number? Okay, so let us come over here. Let me show you one thing, guys. Consider you are trying to establish a TCP connection. All right, that means you have a receiver, a sender, and a receiver. You have a client and you have a server. All right, so you are trying to establish a connection. That means there will always be a TCP three-way handshake. There will always be a TCP three-way handshake. First packet will always be synchronization packet. Second packet will always be an SYN plus acknowledgement packet. And the third packet will be your acknowledgement. Okay, so this is client, this is server. Okay, so now after the connection establishment, you are going to share all the information, you are going to send the segments, you are going to send the data, right? But what is the use of this sequence number? What is the use of this particular sequence number? Whenever you are sharing any kind of data, right, what happens? The order of the data should remain same. The order of the data should not be changed. In the previous session, in the previous part, I have explained what is sequencing, right? Order of the data. In this particular case, for example, let us take in this way. Let me take an example. How are you? How are you? This is the data that you are going to send from a sender to a receiver. This is you and this is your friend. All right, so you're going to ask him. That means first you are going to establish a connection. Once the TCP three-way handshake is completed, then what you're going to do? You're going to share this particular information. You're going to ask him, how are you? All right, now whenever a data is coming from application layer, what happens? It gets broken down into segments when it reaches the transport layer, right? In the transport layer, it's all about the segments if you're using the TCP. Now consider this particular huge data has been broken down into smaller parts like in this way. How are you? This is segment 1, this is segment 2, and this is segment 3. Let us take this example. Okay, that means if you are sharing any of the information, first segment should always be how, second segment should always be are, third segment should always be you. And on the receiver side, he should first receive how, then next is are, then you. Then what happens? Then you have received the data perfectly. It's in order. What if any one of the segment is missed, guys? Then what happens? Then what happens? Order of the data will be missed. If what happens if R is sent at the end and U has been sent in the beginning? What happens if this is the case? If this is the case, right, then order of the data is not there. Simple thing. All right, so to maintain the order of the data, we have sequencing, and also we have this particular sequence number, which is a 32-bit field, and it's a randomly generated number, guys. Randomly generated number. All right, it's a 32-bit field, and you will get a clear picture on what is acknowledgement number also. All right, so now let us go with the sequence number. Okay, it doesn't matter whether you are sending a data or whether you are trying to establish a connection or not. Each and every packet that is involved in the TCP will have a sequence number, will have an acknowledgement number. For each and every segment, you are going to receive what? Acknowledgement. For each and every packet that's being sent will be gone with what? On acknowledgement. All right, so let us take a TCP three-way handshake itself. That means first you have to receive SYN packet, then only you need to be able to receive what? Acknowledgement plus synchronization packet. After sending SYN packet, then you are not supposed to receive only SYN or only acknowledgement. So how do you say that after sending the SYN packet, whenever you send the second packet, it's in order? Consider in this particular case of scenario where your last packet will be for the connection establishment, the third packet is going to be acknowledgement, right? What if your acknowledgement is first and the finally is your SYN packet? Then if this is the case, then obviously order, everything is wrong, right? Even for these particular connection establishment for sync, plus ACK and acknowledgement, you need to maintain the order, not only for this, even for the segments, correct? So for each and every packet, there's going to be a sequence number. All right. So in this particular case, let us take an example. All right. Consider your sequence number. For this sequence SYN packet, your sequence number is 100 something. Let us take an example. Okay. That means on the receiver side, on the receiver side, you have received what? A synchronization packet with the sequence 100. What your receiver is going to do for this particular synchronization packet, he needs to send the acknowledgement, and after receiving the acknowledgement and the SYN packet, especially the SYN packet, your sender is going to send what? The acknowledgement. This acknowledgement is for this SYN packet, and this acknowledgement is for this particular SYN packet, correct? So now in sequence, after SYN, the next packet should be acknowledgement. Consider your sequence number is what? 100 now. Then how will you know that this acknowledgement itself is next packet? How does your sequence work? After 1, it's always 2, then 3, then 4, then 5, then 6, right? This is how it should be in sequence, correct? So here also, after sending the SYN packet, that means even this packet is going to contain a sequence number. Let us take an example of 100 as a sequence number, and for this particular packet, he needs to send what? Acknowledgement, correct? This acknowledgement packet will also contain acknowledgement number, and this acknowledgement number, what it will be? See, whenever a receiver receives this particular SYN packet, he has a sequence number of 100, right? And your receiver is going to add +1. Is going to add 1 bit to this particular 100, this particular sequence number, and this is called as phantom byte, guys. This is called as phantom byte. Always, for each and every segment, you are going to receive an acknowledgement, and always in an acknowledgement packet, there's going to be an acknowledgement number. Even for a sync packet, there might be an acknowledgement number. I'll show you a real example also. Okay, so before that, let me come over here. See here, guys. Sequence number of the first data octet in this segment, except when SYN is present. If SYN is present, the sequence number is the initial sequence number ISN on the first data octet in the ISN +1. Octet is ISN +1. Acknowledgement number 32 bits. Acknowledgement control bit is set. This field contain the value of the next sequence number the sender of the segment is expecting to receive. See, once a connection is established, this is always sent. All right. Phantom byte during the TCP startup and the teardown sequence, a phantom byte causes the sequence number and the acknowledgement number fields to increment by 1, even though no data has been exchanged. Okay. Even there is no data exchange, it's totally fine. A phantom byte will always be added, guys. For example, let me come over here. Let me give a brief picture here how it works. Consider you are sending a segment 1. This is a segment 1. This is a segment 2. This is a segment 3. All right. For each and every segment, you are going to receive what? An acknowledgement. And after receiving the acknowledgement, segment 2 will be sent, right? That means this is how, this is R, this is U, correct? Now for this particular, if on consider like on the receiver, you need to receive what? How are you itself, not how you are or are you how, not, the order should be same, right? For this segment, the sequence number, consider it's going to be 1. All right, it's going to be 1. And now here is going to send what? Acknowledgement. That means here also there's going to be an acknowledgement, right? So on the receiver end, what happens is, for this sequence number, 1 phantom byte will be added. So your acknowledgement number will always be 2. 1 plus 1 is 2, and that 2 will be your acknowledgement number. And on the sender side, he is going to receive the acknowledgement, right? And with the acknowledgement number 2, and this 2 will be the next sequence number. Next sequence number, guys. It's going to be the next sequence number. That means after 1 it should be 2, right? After 2 it should be 3. Now in the second segment your sequence number will be 2, because on the previous acknowledgement you have received what? Acknowledgement number as 2, and this 2 itself will be the next sequence number. And once this person receives the segment 2, what happens? He is going to send an acknowledgement. Now he has received what? Sequence number with 2. He is going to add +1, a phantom byte, a ghost byte will be added. And now what? His acknowledgement number is what? 3. And this acknowledgement number 3 he has received now, right? Acknowledgement number 3, and this 3 itself will be the what? Next sequence number. Next sequence number. So this is how your order of the data will be maintained, guys. Order of your segments will be maintained. See, first is segment 1, you should receive what? Acknowledgement. Then segment 2, you will receive acknowledgement. Segment 3, you will receive acknowledgement. Here the sequence number, consider 1. Here it should be 2. How it will be 2? Because before you receive in the acknowledgement number, your acknowledgement will be 1 plus 1, and this one is called a phantom bit, and this one will be added. So your acknowledgement number will be 2. You have received what? Acknowledgement number as 2, right? Now this 2 itself will be the next sequence number. So here the sequence number will be 2. Can you see the sequence? 1, 2. Now here on the acknowledgement side, I mean on the receiver side, he is going to receive the 2 as a sequence number. He is going to add +1, and this is called as phantom byte. Phantom byte. And now the acknowledgement number, what will be the acknowledgement number? The acknowledgement one number will be 3. And here he has received the acknowledgement number 3, and this 3 itself will be the next sequence number 3. So 1 and 2 and 3. So this is how your sequence and acknowledgement number works. Got it? So this is what your sequence and acknowledgement number do. And to the main purpose of your sequencing is to maintain the order of the data, and also to find out if there are any kind of missing segments or something like that. Okay, if there are any missing segment, then you easily come to know that with the help of the sequence number, right? After 1 you should receive 2. If in case on the receiver side, after 1 if he has received 3 or 6 or something like that, then obviously you'll come to know there is some segments missing, right? There is some segments missing. So we can find out all of these things with the help of sequence number and acknowledgement number, guys. With the help of sequence number and acknowledgement number, I can give you a best example. Let me come over here. This is a live packet capture actually. All right, just I captured it on my Ethernet adapter. Got it? Let me try to filter for TCP. So here you can see so many packets are there. I'm going to take the SYN plus like the connection establishment part. All right. So let me open a SYN packet. In the SYN packet, as you can see in the header, let me open the TCP header. Okay. This is the TCP header. Let me show it here itself. All the fields that are present in the header. First is what? Source port. I told you source port will always be what? A random. In this particular case, your source port is going to be random, and your destination port is what? A well known. If it is 443 on your destination side, you are trying to access what? HTTP. Yes. Then you have a sequence number which is 0. See, this is the first packet, guys. Your SYN is what? The first packet during the connection establishment. I told you, even during the connection establishment, there's going to be a sequence number, right? That means if it is a first packet, obviously it's going to be a 0. Next it should be 1, next it should be 2, then 3, then 4, 5, 6, like that in sequence. But it can be any random number because it's a 32-bit field, 2 raised to the power 32. You can just count it out. All right. So now destination port, fine. Sequence number, acknowledgement number 32-bit, sequence number 32-bit. Then you have header length. See, it's same as here, guys. You can look over here also. It's ditto. All right. Let me come over here. Any random number because it's a 32-bit field, 2 raised to the power 32. You can just count it out. Right. So now destination port, fine. Sequence number,